Hello, welcome to our live streaming. We are streaming at the ITMA Asia Shanghai exhibition. I represent REFOND Equipment Corporation Limited and our booth number is H8F15. Today we will introduce several color fastness related products. And the first one here is the RF1106 gas fume chamber. It is used to determine the fabric's color fastness to atmospheric nitrogen oxide. The nitrogen oxide is usually produced by the combustion of gases. In this test, we use natural gas or butane as the fuel. And to do the test, in our machine there are several different parts. The top part is the test chamber, and below is the combustion chamber, where we have a Bunsen burner and an igniter. And on the right is the touchscreen and also the control chamber. We have a lot of innovations on this machine, and we have a patent for invention and the patent for utility models already issued for this product. For safety, we have implemented a lot of designs. One of them is that we use an explosion-proof solenoid valve to control the incoming gas. And we also have an incoming gas pressure sensor. The incoming gas pressure switch will sound an alarm if the pressure of the gas is too high. This is because if the pressure of the gas is too high, the pressure might cause the gas to leak out from the pipe at the connector, or maybe the gas will even break the pipeline, and it's very dangerous if there's a gas leakage. So also we have backup sensors. We have two gas detectors on both sides, one in the combustion chamber and then one in the control chamber. The two sensors will detect any gas leakage. If there is any leakage, the machine will stop. The explosion-proof solenoid valve will shut off, and the machine will also sound an alarm to alert the user. Also, in the combustion chamber, just next to where the Bunsen burner will be, there is a flame detector. The purpose of that is to detect if the flame of the Bunsen burner goes out unexpectedly. If the flame goes out, then the gas will come out unburned. It is very dangerous in this state. So when doing the test, the user will first put in the samples onto the sample rack, which can hold 24 specimens. And then the user will open the valve, the main gas valve here, and use the ignition button on the touchscreen to ignite the flame. Then you will need to adjust the flow rate using this fine adjustment knob to make sure that the flame is in a blue state, a blue flame. A blue flame have a higher temperature than a yellow flame, and the higher temperature of the flame is what's generating the nitrogen oxides. The main components involved is nitrogen monoxide and the nitrogen dioxide. These two chemicals will be created near the flame, and then it will follow the hot air up into the test chamber. Here, the sample rack will rotate slowly to make sure all the specimens are exposed to the nitrogen oxides evenly. The nitrogen oxide will cause the sample to change color. And during the test, there is also a control fabric. The test should be stopped when the color change in the control fabric reaches a target state. And after the color of the control fabric has changed, you should stop the test and then take out the specimens to see how much the color of the specimens has changed. This is the test procedure. For this test, the one of the most important things is that you need to keep the flame blue. One reason is that the blue flame will produce more nitrogen oxide for the test. And then the other reason is that if the flame is not blue, that means the gas, the fuel, is not burned completely. In that state, the flame will produce carbon monoxide and also some dust, which is very dangerous. And if the carbon monoxide and also the dust in contact with fresh air, it may cause an explosion. So we have invented a micro air circulation system in our machine. So on this side, we have this exhaust pipe, and also inside the pipelines, we have small fans controlled by the software to periodically introduce fresh air into the combustion chamber to make sure that there is enough oxygen for the flame to burn in a blue state. And also the small airflow will also bring up the product of the combustion up into the test chamber to increase the concentration in the test chamber. And in this way, we ensure safety, and also at the same time we can decrease the test time needed and compared to the previous designs and also designs from other manufacturers. And at the top of this machine, you will see a big exhaust fan. This exhaust fan will exhaust all the air out whenever you stop or pause the test. And this door is also magnetically locked after the test for a period of time. So this is to prevent the harmful gas inside from getting out accidentally if you stop the test. So after the test, the door will remain locked for 30 seconds for the exhaust fan to exhaust all the gas inside. You should put this machine in a well-ventilated area and also connect the exhaust pipe here up at the top of the machine. You will see this is our touchscreen control. It's our touchscreen control. We have English version and also Chinese version. In here, you can control the ignition, start and stop of the test. You can also monitor the temperature inside the chamber. It should be less than 60 degrees according to the standard. And here you can also use the jock to move the specimen rack for the loading and unloading of samples. And you can also turn on the exhaust fan manually, and there is also a light inside the test chamber for the observation of the test. You can set the test time and then the chamber temperature here. You can also set some other parameters related to the air circulation. This machine conforms to the testing standard AATCC 23, ISO 105G02, and also GBT 11039. It is has a lot of innovations and is very safe to use and also reliable. That is for this gas fume chamber.